In this video, I like to go over the class activity. So the first one is which route of drug administration is most likely lead to the hepatic first pass effect. So for this one, we know that for the sublingual, because in the sublingual we have like the capillary blood vessel under the tongue, so which allow the drug to be absorbed directly into the body circulation. So that means you can avoid the liver first pass extraction, right? And the oral, yes, right? Because the drug has to be absorbed into the liver through the portal which they may or may not get metabolized, right? So that means they may have like the first pass, right? And the intravenous, that means 100% get into the body circulation. That's no first pass. And the intramuscular, they maybe have a certain type of the first pass, but definitely it's not hepatic related, right? So the correct answer for this one is B, okay? Second one, oral insulin is not applicable. What is a major reason? So insulin, as we know, is biologics, right? So the biologic, of course, usually it's proteins or the peptides, right? So in our GI tract, we have plenty proteins which can, or protein peptides which can digest the peptide or protein, right? So of course, for this one, the is D, right? Okay, so D. So the degradation in the GI tract, okay, for this one over here. Because for the hepatic first pass extraction, because the insulin don't even have a chance to get into the liver, right? And secondly, the permeability limitation. So insulin, because I mean the permeability definitely is not a limitation over there because it get degraded already, right? And insoluble because insulin is a peptide, so usually their solubility is not a big concern. And also, of course, it's not a substrate of an efflux transporter. Okay, so now let's keep going. Okay. So which drug had the higher permeability? So hydrophobic versus hydrophilic. So as I said, our body is hydrophobic system, right? So hydrophobic system, that means we love hydrophobic stuff, right? So permeability, that means easy to get into the body, right? So of course, in this case, would be the hydrophobic stuff is more permeable, right? And the solid form and the free or base form. So because solid form, that means charged, right? Charged, that means polar, right? So non-polar is more permeable, right? Because polar stuff is more soluble, right? Ionized form, that means charged, right? That's also similar to the solid form, of course, ionized form, right? So this is question number 3. So let's see the question number 4. So draw a line to connect the two items with a positive correlation. So remember this. So most important is acids is more permeable in acidic condition, right? Bases is more permeable in basic condition, right? So remember this. Acids in the acidic pH. So that means it's more permeable. More permeable, that means less soluble, right? Less soluble, that means more ionized, right? So that's something I want you to pay attention. Okay, let's see this one. Okay. So this one is here, it's more ionized, right? More ionized, that means less water soluble, right? Less water soluble, that means more permeable, right? So acids in the basic condition, so that means more ionized and more water soluble and less permeable, right? And the bases, of course, let's start with this first. Bases in the basic pH, of course, more permeable. More permeable, that means less water soluble. Less water soluble is more ionized, right? So we can also do like this. And the bases, of course, go like this way, right? Okay. So now let's go to the next question. So which of the following statements are true? So hydrophobic drug can cross the membrane easily than the lipos insoluble. Okay, that means hydrophilic, right? So hydrophobic drug, of course, right? So they are more permeable, right? So this is correct, right? A is correct. And ion charged drug, ionized drug are more permeable, right? Yes, right? So A, B, all correct. And how about C? Basic drugs will be absorbed more from intestine because intestine is more basic than the stomach, right? So this is why basic drug, yes, is more absorption, right? Acid drug has a higher permeability in the stomach, right? Because stomach is in the acidic pH, right? So acid is more permeable in acidic condition. So A, B, C, D, all of them are correct. So the question number 6 is technically is the calculation, right? Then for this one, remember the equation will come from the, from the slides, okay? For over here, you know, when you look at this, although we have so many words over here, but you just need to extract the information that you have to use, right? So for example, for the session 1, so the subject receive a dose, right? Receive a dose, right? So 100 milligram, right? So we can write down like the dose equals 100 milligram, right? So which one is oral dose, right? So we can put down oral, right? Oral, right? And 100 milligram. And the AUC, oral, equals 100 nanogram hour per ml, right? And the same thing for the session 2, receive IV dose 10 milligram, right? We can just put down dose IV equals 10 milligram. AUC IV equals 15, right? Nanogram hour per ml, right? So now, of course, you can either copy through the equation, but of course, if you still remember, basically it's a ratio of their AUC normalized to their uh, dose, right? So let's give it a little bit more space over here. So now the bioavailability, okay, bioavailability will be the AUC oral, dose oral, and the AUC IV, dose IV, right? Okay, so let's so dose IV, okay. Oh, sorry. So now we just need to plug in all the numbers, okay? So over here, AUC oral 100, right? Nanogram hour per ml. Dose is 100 milligram, right? And the AUC IV is 15 nanogram hour per ml, right? Dose IV is 10 milligram, right? So now actually, although the dose is milligram, the AUC is nanogram, but you can see we don't really need worry too much because the units get canceled out, right? Right? So now you can, of course, now it becomes, if you are not very comfortable, you can do like two sessions separately. But if you are comfortable, basically this equals 100 times 10 divided by 100 and also divided by 15, right? But of course, you can do one portion at a time. So the top one we want, right? The bottom one basically is 1.5, right? So now you can get this one will be 68, right? So it's around 68%, okay? So basically it's 6, 8. Okay, so that will be the bioavailable all 67. Okay, so it's depending on how many decimals. Okay, 67. So that's question this one. Okay, so now let's go to the next one. So which of the following is true about the absolute bioavailability? So absolute bioavailability is the bioavailability of a drug administered by IV injection. Absolute bioavailability is actually it's not this one, right? So this is bioavailability of IV, right? Absolute bioavailability can never be greater than 1, right? So that's true, right? Absolute bioavailability, as I said, can be at most 100%, right? And the absolute bioavailability is the bioavailability of drug after IV compared to oral. Okay, so basically opposite, right? Should be oral compared to IV, right? So if a drug is doubled for both IV and the extravascular, absolute bioavailability will be also double. It won't, right? Because if you double the dose, AUC double. But this one you also double, right? So their ratio should be the same, right? So basically the dose is not supposed to affect the bioavailability. So this one, the correct answer is B. So question number 8, we mentioned before, right? But since it's related to the bioavailability, we can do it again, right? Because remember this, the bioavailability basically is the ratio of oral and IV, right? So in this case, so the if the bioavailability 20%, so the equivalent dose by oral, right? So basically the D oral, if you still remember, will be dose IV divided by bioavailability, right? But again, if you forget whether to multiply or divide, you can do both. IV is always smaller in general, okay? So that means dose IV is 10 milligram, right? And the bioavailability is 20%, right? Basically it's 0.2, right? So basically this is 50, right? So divided by, so should be 50, right? Milligram, right? Okay, let's keep going. So question number 9. So among 3 parameters, of course, this one just read my slides, right? So can measure extent of absorption. So basically Cmax and AUC, right? This is Tmax and Cmax. Cmax for both, but Tmax for the rate and the C. So basically this is Cmax AUC. This is Tmax and the Cmax. Okay, Cmax for both AUC for extent and the Tmax for the rate only. So draw I mean this one, so the arrow. So bioavailability increase, this one increase as well, right? Tmax no change, right? AUC increase, right? Ka increase, AUC, Cmax increase, right? Because faster, right? Tmax decrease, right? AUC no change. So K increase. So this one is a little tricky, right? So that means the elimination rate, right? So elimination is larger. That means the drug leave the body faster, right? So they will stay shorter, right? So Cmax usually is smaller. Tmax usually is smaller, but not really that important. But AUC also smaller. Okay, because K increase, that means clearance increase, right? And clearance and the AUC opposite, right? Clearance AUC opposite, right? So that's I want you to pay attention. Most important is the first two. So this one. So rapid and complete absorption lead to rapid, right? Fast, right? So it should be smaller Tmax. Complete, of course, that's more, right? So maybe the Cmax is a higher, AUC higher, right? So rapid and incomplete. So rapid is faster, right? But the incomplete, that means AUC will be smaller, right? And slow and complete absorption. Slow, that means Tmax longer, right? Slower, right? And AUC complete, that means still AUC will be more, right? Slow and incomplete, that means Tmax bigger, incomplete, that Cmax smaller, and the AUC smaller, right? And which one should be? So of course, A looks like B, right? They are so close. So B, same AUC, however, they have a different Cmax, right? And a different Tmax, right? And the C, of course, they have a different Cmax and the AUC, right? And this one, different AUC, right? So correct answer is A. So the next one, which of following PK parameter are routinely compared to assess? So that one, Cmax for absorption rate and extend, right? AUC for extend, right? Tmax for the rate, right? So these three. So number 14. So which are true to establish BE? So for Cmax and Tmax, 90% confidence interval for the test and the reference should be within the 80 to 125. Looks like it. true, right? But actually, remember Cmax and AUC, right? Not Tmax. No significant difference in Tmax, right? That is true, right? So B, true. So for drug with narrow therapeutic window, so so the confidence interval can be tightened, right? Yes. Highly variable drug acceptance interval should be widened, right? Can be widened, right? Cmax, yes, right? So number 15. So which of following is or are recommended with designing while designing the B study? Randomized crossover is preferred, right? That's true, right? Because usually if you can use crossover, right? Crossover has a lower variability, right? That's the beauty of this one, right? Because it's compared by themselves, right? Multiple dose should be administered. Usually it's a single dose. Okay. Study should only be conducted under fasting, right? Because depends, right? Usually I mean, sometimes maybe only under fasting, right? But really depends. Okay. But if you say only, that's probably it's not true. So both female and male should be enrolled, right? Because of course, I'm for this drug, like if the only test you only use for the man for the male, then you don't have to. Otherwise, both, right? Parallel study need more subject than the crossover. Yes, right? So the next one is a 90% confidence interval for this one. We did all of this study, and this one is bioequivalent or not. Let's see. Cmax basically is 80 to 1 to 25, right? We just need to compare whether they're inside the range, right? This one, Cmax, not, right? Although it's close, but it's not, right? AUC, yes. This one, Tmax, no difference, yes. So explain why. Because the Cmax is outside the range, right? So this is not bioequivalent. So that means if you report this to FDA, you won't be able to get approval. So which are true for brand and generic name drug? So brand name drug used to have a patent protection, right? Yes, that's correct, right? Brand name drug had a better therapeutic effect. I would say they should be equivalent, right? So that means the brand name does not naturally mean they are better, right? So a bioequivalent study is sufficient for ADMA, ANDA application for a generic product, right? So usually that's true, right? So it's sufficient, right? ANDA is suitable for brand name new application, no, right? That's NDA, right? Brand name drug allowed marketing name, yes, right? ACE. So number 18 is the calculation. So again, for this one, we have everything already, right? So the dose and corresponding AUC and the Cmax and the Tmax. So for this one, okay, following this one and calculate the absolute bioavailability for oral solution and tablet. So absolute bioavailability basically is oral versus IV, right? So oral AUC over the corresponding dose and oral IV over the corresponding dose, right? So that one, I only show a oral dose, and for the tablet, you can sorry, I only show your solution, and you can test the other. Okay, so absolute bioavailability over here. No, sorry. Solution, okay. So that means solution is AUC over here, right? 32. Because the units are same, so to make it easier, I don't need to go through the unit, right? So over 150, right? And the IV, oh, sorry. So this is a IV, okay. Oral solution is 27.5 divided by the dose 200 and AUC 30.2 divided by 150, right? Then you should be able to get this is the answer is 68, right? Then you can try for the tablet. So estimate relative bioavailability. So relative bioavailability, of course, depends solution to tablet or tablet to solution, right? So if tablet to solution to tablet, that means the solution should be on the top, right? So basically it's 27.5 divided by 200. And the tablet, of course, we can find out what's a tablet. Tablet is 35.5 over 300, right? So for this one, then of course you can calculate. So basically, which is around 116%, right? So you can see the absolute bioavailability definitely can over the 100%, right? But for the uh for the for the absolute bioavailability less than 100%, but relative can be any number. So estimate if the oral solution and the tablet are bioequivalent. So this one, of course, I mean the bioavailability is still like inside the range, but of course it's towards the high end, right? And also you can see the Tmax, they are so different, right? So the Tmax solution is one and the other is two, so it is less likely to be bioequivalent, right? So basically I mean visually check the Tmax are different. Tmax number values are different, okay? So also I will post the answer, but you can try to do this first, then you can check if your answers are correct or not. Okay.